is Neil Mansilla. I'm a dev advocate here at Atlassian. I've worked at all sorts and sizes of software companies, from two-person startups all the way to like very large enterprises with 100,000 employees. And the products I've worked on and supported span from e-commerce, real estate, healthcare, and even like SaaS API management for enterprises. So full disclosure, relative to actual cybersecurity professionals, I am not a cybersecurity expert. However, in a past life, I did have firsthand experience at building very insecure web apps and web services that have been compromised, and thus have developed a penchant and a professional interest in security from both the infrastructure and software side. So speaking of actual cybersecurity experts, here's a quote from Mr. Amoroso, a well-known cybersecurity expert, where he says that the only system which is truly secure is one that's switched off, put in a titanium-lined safe, buried in a bunker, surrounded by nerve gas, and with very highly paid armed guards. And even then, he would not bet on it. And I think the takeaway here is that security is a process. It's an ongoing effort, a moving target, and something that cannot be like achieved, right? It requires ongoing maintenance. But security is absolutely essential, because without it, we're leaving ourselves susceptible to breaches, and breaches cost us dearly. Based on a report that gets published every year, the raw numbers of breaches and the cost related to them has been increasing dramatically. This report states that the global average cost of a breach is about $4 million. But really, another real cost of data and security breaches is trust. So trust is something, as you know, it's not easily earned, but can be easily shattered. So a single software vulnerability or data breach can cause irreparable damage to an organization's reputation, eroding that customer trust. So it's crucial that we're prioritizing proactive security measures, doing regular vulnerability assessments, and we're very transparent with our communications to build and preserve trust with our customers. So in fact, Atlassian has a trust center. It's where we provide the latest information on security, reliability, privacy, and compliance for our products and services. And it's probably a very useful resource for you as well, if you're building on top of our platform and offering your apps to mutual customers. So in the Trust Center, you're going to find details about our security practices, from product security, ecosystem security, security intelligence, information even about like our red team. That's a team whose mission it is to increase the resilience of Atlassian against sophisticated attacks, and they act like attackers and do their best to infiltrate and compromise all of our critical systems. And that does not sound like a totally awesome job. It's a really fantastic resource full of like useful and relevant information for anyone here that is truly interested in improving the security posture of not just your apps, but perhaps even your entire company and operations. And in that, you'll find, the security, reliability, compliance, and privacy. We're really kind of focused in on the security area here, but all of this is very, I think, apropos and applicable and useful for you. So next on the agenda, we're going to do a general framework overview in terms of the Atlassian framework and the apps that you build on top of our platform. So first, a little bit of history about our app development platforms. It's hard to believe. I actually have a shirt with that very first logo. Not that I've been to the company that long, but some old swag laying around. And I thought, wow, they really need to update this thing. Notice I don't have the latest A on there. So a little bit of history. But back in 2001, if you wanted to, before plugins even existed, if you wanted to extend Jira, you'd have to modify the Jira source code itself. And it's something that we made available to our paying customers. And so you customize it to your liking. Want to build or feature app, just crack open the source code and get it done. And a few years later, there was a formal plugins architecture built so that you didn't have to necessarily hack on the source code. It was a Java implementation of a plugin system written from scratch. And then a couple years after that, the second generation called Plugins 2 is an OSGI-based platform, and plugins written in Java still, and it's still in use today. Like, this is not something that's antiquated. All apps that you see for on-prem products like Jira, Confluence, or Bitbucket Data Center are built on P2. So if you're looking to build an app that runs on our on-prem products, you'd be using the P2 framework. And the reason I'm talking about these things is because the first few things that I mentioned are all on-premises behind the firewall. And then, of course, when we launched our cloud products, we created a third generation framework called Connect. It's web-based, it's loosely coupled, language agnostic. You can build an app in any language you want because you're hosting it yourself. You build the app, you host it on your own, and through the Connect framework, that's how it extends our products. There's both like UI and REST APIs that allow your Connect app to communicate with with the host product. And most recently, the generation of our platform that was released in GA or generally available in 2021 is called Forge. There are some advantages that Forge has over Connect because it simplifies development. There's some improved performance, enhanced security. The fact is that you also don't have to run the infrastructure yourself. Forge was completely built with security in mind. It's a FaaS platform, a functions as a service, and in that part of the platform, it takes care of authentication, identity, scaling, and the multi-tenancy. So there are two cloud development frameworks we have at Atlassian. So you can, the first one, as I mentioned, is Connect. You can build the apps in the language of choice, requires you to deploy and run the app on your own servers. The integration takes place through the Connect framework, and you're responsible for properly implementing authentication, which is done using JWT or JSON Web Tokens. You're responsible for scale, for dealing with multi-tenancy or isolating the customer data. And the other our newest framework is called Forge, and that allows you to also extend the products. However, your app is fully hosted by Atlassian, and Forge generally takes care of auth, identity, scaling, and the tenancy part. So as our products and customer demand has been transitioning more to cloud, we have to think about more about how Atlassian and its partners who build apps for our products, how we work together to ensure that our mutual customers' data is safe. As I said, with our on-prem products, you probably don't have to worry about that too much because these things are running mostly behind a firewall. So in fact, as a partner or a developer, you don't have access to to your app. It is literally installed behind the firewall, and the data, generally speaking, does not egress out. You don't have access to that. So even if you're just building, oh, by the way, if you're building, I know I'm kind of talking about marketplace apps, but even if you're building a custom Jira or Confluence app just for use for your own company, security should also be of utmost importance to you because that data is being accessed by your employees outside of a corporate firewall if you're building cloud apps. So we have several doc pages dedicated to partners to help you improve the security posture of your apps, including a list of security requirements for marketplace apps, data privacy guidelines, and security guidelines that are all up on developer.atlassian.com. In putting this presentation together, I just didn't realize how much we actually have and how much has been published just in the past few years on this, including the Trust Center on Atlassian.com, as well as all these things on developer.atlassian.com. There's no shortage of resources available. In fact, it could feel like a little bit of information overload. And if you're a marketplace partner and you have access to the partner portal, there's even more information about certifications and compliance like ISO 27001 and SOC 2, et cetera, and things about the privacy and security tab that's on Marketplace that was recently launched. So no shortage of information. Perhaps it could even feel like a little bit overwhelming, but lo and behold, there's plenty of people here at Atlassian that can help you navigate that on your journey to improve your app and your company's security posture. So the security requirements document contains very specific requirements that apply to cloud apps that are listed on Marketplace. So even if you're not listing an app on Marketplace, these things are still relevant. They're just important to understand and follow if you're building apps, even just for internal use. Things like authorization, app security, data protection, and vulnerability management. So this is they're fairly technical topics on the security requirements page. On that page, it also has things that are specific to Connect apps and Forge apps that egress data, meaning that the Forge apps interact with external services. This one is often overlooked, but I think it's super, super important. The security guidelines are intended to help our partners for some of the more stringent security risks and checks that our customers are completing as part of their procurement process. So it's perhaps maybe not just enough that you build an app that is secure, but it also, that your practices as a company or employees is also secure. So things that we talk about on this security guidelines are things like, they're kind of mundane topics, but I mean, they're super important. Account and workstation security, right? Very important. If either of those things are compromised, a malicious actor could access your code repos or adversely affect your infrastructure. Bad actors could access customer data, modify your code, gain access to other services. So guidelines like this, things like password management, multi-factor authentication, and even antivirus software and firewalls, like these things are covered there. And, relevant to app security specifically, maybe not, but to the posture of your entire company and the fact that if you're a marketplace partner or a consultant that's selling your building custom apps, your customers are going to want to know that you're not falling short in that regard in terms of your security practices. Much of the same things can be said for infrastructure security in terms of their importance. And last but not least, we have the data privacy guidelines. I remember when GDPR became a thing, boy, we really started beefing up on information about, privacy practices and policies, minimizing the data collection and how we handle personal data. All of these things are super, are very important. And even though they aren't necessarily, I think they're adjacent to like security requirements, they're just as important to keep in mind. It's another dimension that I think is often overlooked until either it's too late or until a customer says, "Hey, by the way, what are your data privacy guidelines?" So let's talk about app-specific cloud security issues. Perhaps you've heard of OWASP. It's a foundation, stands for Open Worldwide Application Security Project, which is a mouthful, which is now I know why they call it OWASP. They work to improve the security of software. And what they're probably best known for is their OWASP top 10 list. It represents a broad consensus of the most critical security risks to web apps with data coming from industry surveys. And on the left, you'll see the list that they compiled back in 2017 and how it compares to their latest one that they published in 2021. Much of the same things, but they did, kind of shuffle some of the category names around. But in terms of like the ranking and importance, all of the top things are pretty much still there. And it's nice because on the OWASP website, for each of the vulnerability categories, you can drill down to better understand what their impact is, as well as get detailed examples of what types of vulnerabilities fall into each of these categories. So while the OWASP list is extremely helpful, like in a broad sense, you're probably wondering like which of these vulnerability categories should you be looking out for when it comes to building a cloud app in the Atlassian ecosystem. I'd argue that all of them are super important. They are. And in fact, I'm going to tell you that the top 3 of the vulnerability areas are in these red circles. And we get this data from the bug bounty program, which I'll talk a little bit about later. It's broken access control, injection, and identification and authentication failures. Again, these are categories. So within those categories in OWASP, you'll find like, more specific vulnerabilities that are kind of listed within there. And within those categories, the specific vulnerabilities are that are at the top of our list that we see in marketplace apps are cross-site scripting or XSS, insecure direct object references or IDOR, and then broken authentication and session management. I don't know if they go with BASM on this, but BASM. Again, these are the top 3 vulnerabilities identified by global security researchers that are paid bounties to find critical bugs in marketplace apps. So these are the top 3. So exactly what the heck are XSS attacks? I'm sure you've heard of them. I'm not sure how deep you've dived into it, but it's when an attacker injects malicious scripts that execute on a user's browser, allowing the attacker to potentially obtain sensitive information or release information that they shouldn't get, and perhaps even egress that data out. XSS attacks are on the OWASP top 10 under the injections category. Injections was number 1 back in 2017. I think it might have gone down to number 4 in 2021. And it also happens to be our most common app vulnerability reported through the bug bounty program. So what type of XSS attacks are there? Because of course, there's not just going to be one. The first is what's called stored or persistent, which means that the malicious injected script is stored somewhere on target servers. Perhaps the attacker entered the script into a form field and then stored it, or perhaps they inserted the malicious script in some other way. In the context of Atlassian frameworks, these might be stored in Jira entity properties, or perhaps even in the forward storage API, or possibly even saved in your apps database. Just because one part of an application that stores data might look out for malicious scripts, you can't assume that everything that's stored has been sanitized and cleaned. So anyway, that's what's stored and persistent. So when the data with the malicious script is retrieved by your app, if it's not properly screened or sanitized, the script could be executed in the client's browser. The second type is what we call reflected or non-persistent. So non-persistent meaning that the malicious code was not pulled from a persistent data store. And this occurs when an app renders a page with data taken from, let's say, a request URL, request headers, request body, without proper validation or encoding. So for example, let's say a user clicks on a link that has malicious code embedded in it. That link goes to a completely legitimate website that the customer or the user trusts, but that website does not sanitize the request. It doesn't sanitize the URL, which contains the malicious script. And it ends up rendering a page on their browser with that malicious script. And when it executes on the user's browser, things go south, because it looks innocent to the user, but the outcome is that injected script could allow that attacker to potentially steal information that is at the domain level of the website that they're on, perhaps even authenticated with. And the third type is DOM-based, DOM meaning document object model. And these are similar to the last one that we just talked about, the reflected, but occur when an app uses JavaScript to dynamically modify the DOM, the document object model, of a page, the page tree of, basically, inserts things into HTML without properly validating or sanitizing the input. So these are fully client-side attacks, and again, could result in customer data being accessed by an attacker. Again, I'm sure you've heard of XSS. It's probably the most common vulnerability that is talked about, but yet it's still our number 1 on our list, and still number 4 on the OWASP top 10. So let's jump into a demo. What does XSS vulnerability look like? There's a link to the repo. We probably could have done this outside the context of an Atlassian, Jira instance, but just for giggles, we'll do it there so you can actually see it. That repo just has, it was created just with from the command line, and I just popped in a few of these static HTML files into the public folder and modified the descriptor. And I'm kind of getting into something that isn't necessarily security related, but if you're just getting into both Connect and Forge, seeing some of this stuff doesn't hurt. And so now that I have that in my credentials file, which this is a security workshop, so I won't load that, but in that credentials file, I hid my password. is the kind of like the target instance that if you have this credentials.json file and you start the app, it's a fantastic little convenient thing it does. It'll upload the app for you onto your instance. And this isn't an actual password. It'll be your API key for your Atlassian account. Okay, so let's give this a whirl. I think I just have to install some dependencies, and then I'm gonna do an npm start and pop this thing onto my dev instance. Let's just give it a second. Okay, here we go. Again, security talk. You're going to see some keys in here, but let me assure you that this is all just demo accounts that I created. And even if you were clever enough to hack into this stuff, you won't find anything but a bunch of hello world content on Confluence and Jira. All right, so we have this here. Let's hop over to this. Load this up. Okay, I'm going to make this a little bit bigger just in case. And there's the app. By the way, I'm just going to go into manage your apps so you guys can see this as well. If you haven't done this already, again, if you're new to development on the platform, you have to go to this app section of Jira, and you'll go to settings and just make sure this thing is checked right here, enable development mode. And all that does, it allows you to essentially like sideload apps like we just did that are not marketplace apps. And there it is, the one that I just uploaded. So let's go into this. And we're going to take a look and see what an XSS vulnerability looks like. So let's see, let's just type in some input here. This is just an input field, text area. When I press this button, it's going to fire out some JavaScript that will copy the data and print it here at the bottom into another div. So let's say testing. Oh, 1 second. There it is, testing. So let's say H1 testing. There it is. Some style applied. So let's put something that is malicious. So let's go to, I have some examples in the README, and here we're going to have a very malicious set of code that's going to alert cats. So in this code, it's going to try to, this is the bad guy code. It's going to, it's an image, it's a HTML image tag, source of foo. Foo doesn't exist. It's going to throw an error, and then that error is going to run this JavaScript code of alert cats. So let's give it a whirl. And what do we see? Below, that's the image that tried to load, but really at the end of the day, the bad thing that just happened. It showed this, it ran the JavaScript code. Obviously not what anybody intended on happening, right? Like normally if I just had an image that was broken, you just have a broken image, but actually this is the malicious code right here. That seems innocent enough. Like what the hell, what damage can you do with just alerting an alert message about cats? But here's a Jira specific issue about this vulnerability. So let's go and we'll break down this code here. Same deal, it's an image that will throw an error because it doesn't exist. But this time it's going to use this ap.request, which is the connect JavaScript function to make a REST API call. And it's going to call the myself endpoint, and it's going to pull out the display name. And so let's try that out. It says, hi, my name is Neil Mansilla. And it pulled that from the API. So that is this code, essentially, this malicious code now has access to other JavaScript resources or other resources that have scoped access on this page. And this just happens to have API access to this Jira instance. And in fact, to this user. So it doesn't have to be just the myself endpoint. It could have been anything about issues, right? And then again, well, this is, trapped inside of this, trapped inside the context of this frame. But if they were able to potentially store this data somewhere else to pick it up later or egress this data out, that there indeed is a breach. So what can we do about this? There are ways to mitigate this, and I'm going to show you several of them. So first thing we probably should not do is just take it at face value. And let's take a look at the code, actually, what happens here. On that panel, HTML, right here. So we go down to the input. So here's the input field. It's the text area. And there's the button. And when that button is pressed, this JavaScript fires. And so we bind this event listener on here, and it just fires this. And all this means is it's going to grab the input, store it into a variable here, get the output. The output is the hidden div that's below that we kind of are copying the data into, some console logging. And here's the, I guess, the culprit, if you will, right? We're just taking the output element, the div, changing the inner HTML to whatever the heck the user inputted here, right? And that's why the image renders or tries to render, and that's why the JavaScript fires, okay? So we need to improve this dramatically. And one way that we can improve that is by essentially sanitizing it. So let's take a look here to say if we were to sanitize this instead. So again, let's just do a test here. Still looks like, oh, 1 second. So what's different here? What did we do? There's something that's distinctly different about this, and you notice there's no greater than or less than signs. So let's take that malicious code from the README. We'll do the Jira one, and let's see what comes out. So clearly what this function is doing instead on the sanitized is it's seeking out less than and greater than signs. And it's still all here, except it's not going to execute. So how is that done? Again, sanitize. So here in this one, only certain characters are allowed. And everything's the same, except we create this regex, a regular expression, an allow list. And this basically says that it's uppercase letters, lowercase letters, digits, and spaces, and only these punctuation marks, okay? So the regex basically says, from beginning to end, from caret to dollar, it can only match, it has to match this pattern, okay? And let's take a look. So if the content, which is what the user entered, matches that regex, then go ahead, copy it all over. And we can test that by just putting something that doesn't, that complies. This complies. It should be identical, right? If it doesn't comply else, it's going to replace, it's going to actually look out for specific things. Less than signs, replace it with a space. Greater than sign, replace it with a space. There are a million ways to do this, but generally speaking, this for the sake of this exercise, we're calling this sanitization. We're just doing a regex check, and then we're actually ripping out any less than and greater than signs. And then only after we do that do we then copy it over, which is why this works. Awesome. Another thing that you can do, perhaps might be even more simple than that, is using, instead of using inner HTML, we use inner text. And by using inner text, it strips out a whole bunch of tags and other elements that are style related. So let's just try this out. Testing. Oh, there it is. So H1 testing. And look, it retained it, right? Because, and let's try this. So it did copy it over, but it didn't do it as HTML. It did it as literal text instead. How does this work? Because it sure looks like HTML code that should have executed. So let's go and take a look at that. And this is the escaped. So here we use inner text instead of inner HTML, which retrieves the text content, and it treats it as, it converts it to literal text, reducing the risk of malicious code being executed. So caveat here, OWASP says that there are still ways that this could be compromised, but again, I don't think that there's just one way to do this. I think that there's probably multiple, strategies you could employ if you're doing this stuff by hand. So here we go. We just replaced inner HTML with inner text, and that was it. That was the only change we made. And essentially kind of it escaped those things out. And I think that if we're probably to like inspect this, we could see, I'm gonna try to make this bigger, maybe what the values are. Yeah, I guess I really can't see that. Anyhow, it is definitely escaped out, and it's not like pure HTML. These symbols here are not less than signs that are evaluated and as HTML code. And then the last example is this one right here, which is validated. And how is this different? So let's do testing. There we go. And let's say let's put in that code. So what's different here is that we're not just changing the data and storing it, and where you can actually see like a clean version of the malicious injected code. We're just basically saying, no, it's invalid. And so this is more of a logic thing, decision to make. And all we're doing here in the code is that if you, again, applying the same regex, but the logic is a little different. It's not, hey, if it matches the regex, let's copy it over. If it doesn't, I am in the wrong one. Perhaps I'll validate right here. If it doesn't match else, it's just going to replace with invalid input. So taking no chances, and also, I guess maybe equivalent to like when you're trying to type in a password and it doesn't meet all the requirements, it's not going to save it. It's going to tell you that it's invalid. Similar here, right? We're validating it before we make any kind of persistence statement and saving it like we did in those other examples. Again, incredibly simple in terms of like, I guess, understanding how the vulnerability takes place. And it seems that the mitigation strategies are quite simple as well. Yet it's still our number one vulnerability that we have through our bug bounty program, and it's still at the very top, or a part of the injection OWASP list at number 4. So I don't think that there's so many different attack vectors. This happens to be one I think that is just so simple to both implement, but as you see, it's also fairly simple to mitigate. The nuances are, particularly on stored, is if you make assumptions, like incorrect assumptions that, hey, this particular part of my app definitely sanitizes the information before it gets stored. So therefore, when I retrieve that information next time, I shouldn't expect any kind of malicious data. That's a very bad assumption. And in fact, I know that in real life situations where that has been made, and assumptions that some data is safe, but it's not. So essentially, checking has to be done not just at storage time, but perhaps even at retrieval time as well, before you render it in any user's browser. There is another one that you can implement, another mitigation strategy, and that's with CSP, or content security policies. If you're not familiar with that, you can search CSPs online and find out all about them. But essentially what it says, I'll show you what it looks like here in app.js. So inside app.js, which is kind of the boilerplate code of Atlassian Connect Express, I just kind of intercepted this so that anytime a page is rendered, I'm going to insert a custom header, and with the key of content security policy and this value here. And basically what this means is that the browser is going to check that, going to enforce, I should say, where, like, say, scripts could be loaded from. So scripts could be loaded from self, from the host that this page is being loaded from, from code.jquery.com because we have some remotely loaded jQueries, as well as this host name as well, because we pull in the all.js or the connect JavaScript source file from that host name. And what's missing in here is unsafe inline, which basically with this, by putting this in place, it would restrict any kind of inline JavaScript from running. So you can do it there at the application level. Additionally, you can implement it at the HTML level, which I think you can add like a meta tag here. So did I have one in here? So yeah, you could do something like, you know, at this level, you can actually put in meta tags and then put in a CSP. Ideally, you're doing it at the web server level, so it kind of applies across the board, and you're not just kind of cherry picking individual pages as to to implement or to put a policy in place. But again, content security policies super useful for restricting where data can be, or where libraries can be loaded from, and this can help ensure that this can help mitigate XSS to a large degree. But I think that the combination of both the things that we talked about earlier in terms of sanitization, as well as CSPs, are just, there's more tools that you have to put on your tool belt. I'm sure there are, like I said, I'm not a cybersecurity professional, so I'm sure that there are even more things that you can implement to mitigate XSS. Again, deceivingly simple. Why in the heck is it still number 1 on our list and number 4 on OWASP? I think it's just because it's so damn easy to perpetrate. And okay, let's go back to pre-zone mode. Okay, so again, as I mentioned, for those that are just getting started and messing around with the Atlassian platform and building your first apps, perhaps using this repo was a bonus. But you can actually test these things, even take those static HTML and JS files and just run them on your browser. So the ways that we covered to mitigate XSS attacks, we can clean up the user data. We used a validator. Don't accept potentially malicious data. In our examples, we applied regexes to only look for certain characters that were allowed. We scrubbed data looking specifically for less than and greater than signs. Again, and we also utilized like inner text instead of inner HTML. Again, gosh awful amount of strategies that you can tactics that you can employ, and these are just a couple. Talked about CSPs or content security policies. Again, these can be sent from the web app side as well as in the header, or on a single page as a meta tag. I think the former, the web app side, is a little bit more reliable than an inline CSP in a meta tag. But I guess your choice. And while we didn't show this in the demo again, but I did mention it, sanitizing stored data that we retrieve. So in other words, just because it's already persisting in your data storage, like a database or a Jira entity property or a Confluence page, it doesn't necessarily mean that it's been sanitized. Even though your app might be awesome at sanitizing, other apps could be storing data in these places. And or if the attacker could have inserted it in themselves on purpose. And there are various mechanisms that could be available for them to do that, right? It's not just going to be your app and the thing that you built that's storing data there. So that's XSS. Let's talk about the next one. This is number 2 on our list that the security researchers found as vulnerabilities in marketplace apps, and that's IDOR. Insecure direct object references. Fantastic name. So an IDOR vulnerability takes place when a server fails to validate incoming HTTP requests to access objects. So I'm trying to think. It allows a user essentially, or an attacker, to get access to data that they shouldn't, and often simply by just changing the ID parameter. So as a result, they're going to get directed to objects or data that they probably shouldn't be seeing. And obviously, in very bad cases, it can contain sensitive information, as well as perhaps other users' information. So there's a bunch of different security gaps that can cause this, but it kind of looks like a common example is like the one that's being shown here from like OWASP, where someone just says, "Hey, get me the document 1000, please." And like, yeah, sure. And then they just change the ID from 1000 to 1002, and the server just serves it up. It doesn't just have to be in a query string. I mean, these things could be in headers. They could be in post body requests. And they don't even have to be integers, right? Even if a document ID is semi-obfuscated, like with a simple hash, if the attacker knows that hash algorithm's discovered and they have some idea about, what your, what the base ID numbering system is, it's just as easy for them to start throwing a bunch of hashed numbers at it. Even if your GUIDs are super, super long, it doesn't. If they figured out how you generate those, then it's just one extra instruction that their script needs to apply in order to start traversing your service for all the information that they shouldn't have access to. And in a lot of the examples, if you start researching these things, you'll see this kind of typical thing where it's just URL $, ID equals 1000, ID equals 1002. But it's not also very unusual for developers to store ID information inside cookies. So an attacker could also modify session data. Again, could potentially reveal records they should not have access to, or worse, completely impersonate another user. Again, if you're very security conscious and your team has implemented strategies and tactics to avoid these kinds of situations, good on you, but this is still our number 2. And I think that this is either number 1 or number 2 on the OWASP list. Not IDOR specifically, but just let's go back to that list really quick. Broken access control is what this falls under. I think it's a combination of broken access control and a little bit of around identification and authentication failures, and I'll tell you why. But IDOR falls under broken access control according to OWASP, and that is number 1. I mean, that's telling you something. So again, I'm sure in your head you're thinking about strategies that you might implement to avoid this from happening. It's still happening in aggregate across the world, and it's number 1, and on their list, number 2 for us. So in the context of the Atlassian framework, an IDOR vulnerability in conjunction with something like privilege escalation is particularly important. So in the security requirements doc, there's a section here that says that talks about forge apps that egress data to external services. And what's being called out here specifically is your app should really be by default be making API calls as user. So essentially, any API call that it makes, it impersonates the user that it's performing the action for, the user that's using your app inside the product. When API calls are made on behalf of the user, all the privileges are applied. So, they can only access certain spaces in Confluence or certain issues or projects on Jira. In contrast, your app could have access to all of the things. So when you make an API call as app, you really, you could be exposing information to users that should not be seeing that information. So it's important that you are very cautious about this, and that it's not bad as per se that that as app exists. There are reasons for having essentially escalated privileges or admin privileges if that's what your app is scoped for. But when it comes to user functionality or product functionality that is applicable to a user, you really have to make sure that you're utilizing the right method or the right scope. There's an equivalent to this on the Connect side, called user impersonation, and you would set your scope and your descriptor as act as, to have act as user, and then you would get a JOT bearer token that any calls made with that bearer token would be specific to that user, right? So if you were to make an API call, your app, your Connect app, or to make an API call with the app's JOT token, like it's like as app, right? But if your function of your app is supposed to be at the user level, like the user that's using your app at that moment, you're going to want to implement impersonation. And then moreover, inside the security guidelines, security document, JOT token must be validated. So again, your responsibility, right, on your side, because this is not this is running on your end, and you need to make sure that you're validating all the permissions, that the users are that the app is making the right call on behalf of the user, if that's what the intent is. So very important. Again, gosh awful amounts of resources to peruse. But also you can, if anything seems particularly confusing or conflating or whatever, you can also go to the developer community forums and ask questions there, and we can perhaps help untangle anything that seems confusing, because there is a lot to comb through data-wise. So let's talk a little bit about what you should do and what's next. So security, it is a journey, and there's some valuable resources that you really need to take with you. When I worked at a company that worked with banks, there was a lot of budget around access to commercial tools, very, very expensive commercial tools to do penetration testing, network testing, load testing, etc. But OWASP has, they also have some free tools as well. So on that second link there, they have DAST, which is their dynamic application security testing tool. ZAP stands for Z Attack Proxy, and it's probably one of the world's most widely used web app scanners out there. It's also free and it's open source, right? It's a pen test tool with lots of lots of power in like wide ranges for automation. But they also compiled an enormous list of tools, actually. There's like over 100 on this list of both open source and commercial. And the reason I'm mentioning these tools is because this is not an immature space, right? Like these tools have been around for a while, and these can really help you to increase your security posture of your apps. And even if you're like me, you're not necessarily a security expert, you could become more expert by actually utilizing industry standard tools. There's two things. There's a OWASP has both Juice Shop as well as one that begins with the word goat, and I can't remember what it is. But these are just apps that are intended to showcase vulnerabilities that are on the OWASP top 10, so that you can learn how these things are I guess how they're vulnerable, and then how you can mitigate them, and then you can actually throw some of these testing tools against it too. But yeah, the Juice Shop is a fun one, and it has the entire OWASP top 10 vulnerabilities in there, and then some. I mentioned the bug bounty program, and a bug bounty program is probably one of the most powerful tools to detect vulnerabilities in apps and services, because these are professional security researchers. I mean, I think in layman's terms, we call them these could be like white hat hackers. No, this is what they do for a living. They just, these professionals know how to find vulnerabilities, not probably by hand as well as by tool. These are not, just script kiddies. These are really, really talented people that know how to break into things, and they help to improve the security posture of your apps. So on the Atlassian Marketplace bug bounty program, we collaborate with BugCrowd on their platform. And so it's a collaboration between Atlassian and our marketplace partners. And we leverage, crowdsourced vulnerability discovery methods through this bug bounty. It's hosted by BugCrowd. That's a SaaS platform to crowdsource, security researchers that will, find vulnerabilities in your apps. Atlassian covers all of the costs of the platform costs of BugCrowd. It's just the partner's responsibilities to do the bounty payouts. So, like, depending on the severity of the bug, it's a P1, it's a P2. There are certain recommended amounts that we have for partners to pay out to the researchers, but it's also customizable. You can customize the payout range based on the vulnerability severity levels. Can't say enough about this. Again, this is where we get the data in terms of the fact that I was telling you that XSS is number 1 and IDOR is number 2 and broken access and session management is number 3. It's because of these researchers. And it's not, these are not like small paltry numbers, not dollars wise, but it just occurrences, right? These things are common, and the bug bounty program is helping our partners to, again, increase their security posture, not just for that single app, but if they have multiple apps, and then just improve things overall. And again, the guidelines, I can't tell you like how much information is available to you. There's no shortage of information. So whether you're just kind of kicking the tires and thinking about building your first cloud app to extend an Atlassian product, or you're already in full swing and a seasoned developer in the ecosystem, the numbers don't lie. Even if you're a seasoned veteran developer or company, these are not just small companies that are exposing or having these vulnerabilities in the apps. These are all kinds of our partners have these issues. So I think that understanding what these vulnerabilities are, kind of like what our posture is as a company and what we do, because if you go to our trust center and you see like how much investment that we put into security, reliability, data privacy, et cetera, and the amount of information we share, like about how we even structure our team, kind of the people behind it, this is extremely useful information. And then lastly, I mentioned it just for a moment, but like, you're going to see this more, and we are seeing this more in terms of the certifications. This is something that some of our customers are definitely looking for. They're looking for it from us, which is why we probably spent a lot of time and resources getting SOC 2 compliant and getting our ISO 27001. And we're seeing more of our partners go down that road too, because the customers are demanding it, not just because it's just about checkboxes, but it's also just making sure that both from a security requirements and like policies and processes as a company, like that you can be trusted by our customers. And you might think that this is just like, these are just mega enterprises. Yes, definitely mega enterprises have the expectations that have a secure app and that you're operating in a secure manner. But we're also seeing some SMBs, some small, medium businesses that are also, they're also very concerned about apps built by second party and third party partners, and how their data is treated, or how that company conducts itself, both from from security and data privacy guidelines wise. So ensuring proper security for a cloud app definitely can be daunting. It's challenging. Rest assured, there's, like I've been showing you, there's vast amounts of resources that are available to you. And I think that making the proper investments, including education and awareness, are absolutely crucial. Thanks so much for joining the session today, and thanks for your interest and investment in making the Atlassian ecosystem more secure for our companies, yours and ours, and of course for our customers. Take care.